Hey guys, what's up? This is Tomer, and I want to continue discussing with you distributed systems in practice because this is a very interesting topic. The biggest tip I can give you about distributed systems, and actually if you would practically ask me, hey Tomer, what is the biggest tip that you could give us about distributed systems? So of course, some people could tell you it's about tests, it's about the availability, it's about so and so, but I would claim that one of the most underrated tips about distributed system would be to keep it predictable. And what do I mean by keeping the system predictable? If you have a simple code that runs on a local machine, and not only it runs on a local machine, it might be a single function that you run. Okay, non-multi-threaded, nothing. It's just a simple function. It's very predictable, right? It's very predictable, and once you try to build a real app, you increase the unpredictability of that code that runs, because you find yourself adding threads, you find yourself adding asynchronicity, you log stuff and you have logging, and those logs might boil up and capture all the disk space, and this is, hey, first single unpredictability. Now, how would you test that the logs are capturing the whole file system? So we try to get a mindfulness into predictability in distributed system. And when you consider then many questions such as how should I log, how should I monitor, how should I handle failure, if you have this tip in your mind, then I claim that you would be able to come up with some of the best solutions. And even if you would consider having unpredictability in your system, at least you would be aware of it and would know how to handle it. So you maybe increase the logging or monitoring in that area of the system. So let's take a specific case. You go to your favorite news website and you try to get the news. Okay, you just access it and it's very slow. Okay, it could happen with any website, or it's crashing. What could happen is that there is a failure, and in today's world there are, because we are dealing with heavy microservices systems, then it could be the case that an internal service that has failed has caused a failure in an external web server, and this has reached your client. And if you would examine the code, you could see that they have the retries in place, they have failovers, they have the fallbacks in place, everything is like in place, but still it didn't function. So how do you handle failures? Because a distributed system, any distributed system, is bound to fail, just like the human body. It's bound to fail at a certain point. And what do you do at these points, especially at these points of integrations? So you could retry. So if you have a failure, you could claim, okay, so if I have a failure, I would retry the call. Okay. And while retrying may sound like a good idea, note that we have broken the predictability rule, because you will take into place the retry only when the failure happens. Okay, if you use a standard retry. And this means that if the failure won't happen until months into the lifespan of your application, or even years, then it would be like the first time that the retry happens, and who knows what would happen in the upstream servers that call this. So there could be multiple solutions and multiple things that you could take into account. One of them is that you can say, okay, so I won't do a retry in this case. I will have a fallback logic. Okay, I will simply, in that case where I was hitting the cache, okay, and the item is not, and the cache, it has a failure, okay, or the fast server that I was accessing had a failure, I will access a secondary server that is slower, yes, maybe directly to the database that is slower, and I will fetch the data from there. But again, we have broken the predictability rule, because this means that in most cases, or in many of the cases, we would hit the good fast server, and only in the failure cases we would hit the slower server. And again, who knows what would happen? You would need to monitor this very closely and see all the metrics and see that everything is functioning well, because we have broken the predictability rule. This can actually cause more problems than it try to fix, because all the servers, they call these servers, that call this server, and I'm now trying to retry the command, and are now calling different servers that might be slower but more reliable. The whole system is behaving differently than what you're testing, that what you're expecting, that what you used to do every day. And this can happen especially in cases where you have a high load on the server. So especially in those events where you have a high load, many customers are coming to your servers, these are exactly the times that you have this unpredictability, and these are exactly the times that you want to be the most predictable. Okay? And in any case, I could ask you, if you went to this fallback logic this time that all these customers came, is this fallback logic good enough? If it was good enough, then why didn't you call it at the first place? Okay, because and there are events. I'm not saying that there are no events that you should do retries and fallback. There are such events. For example, if you know that for sure it's a temporal problem, then retry is perfectly fine. You can do the retry. Okay, because it was inherently a temporal problem, and once you do the retry, it's fixed. It's not retrying over and over again. And also, when you do the retry, you need to ask yourself, did I test this retry? Was my logic actually testing this? I mean, when I have the system test, is it running through the retry? No, because it's very difficult. You need to simulate the error, you need to simulate the exception, and then only then you would have the retry. And also the same for fallback. If you have a fallback logic, even if it's okay, you have to simulate the error, and only after you simulate the error, you have the retry and the fallback. And I promise you that in most cases, when you check the tests of the codes, you won't see it going through these paths. So instead of you trying to come up with sophisticated retries and sophisticated fallbacks, why don't you just improve, think harder about the main problem that you have and improve it. If your cache is not reliable, improve it. Okay, if you're accessing a server that has a disk space where disk space can eventually be fully full, then let this server fail. Let the server completely fail. Let the whole request completely fail. And then have a new server spun up, or find the root cause and clean up the logs. Monitor it better. You could have those retries and fallbacks as long as you monitor them carefully, and you see exactly when they happen, and the minute that they happen, you fix the problem, or you have massive tests that test them. But it's very difficult to do this, and you're going to spend resources and time on it. So spend the time on the main flow. Okay, because all this would be unpredictable. A very minor thing like printing an exception into the logs, this is unpredictable because this only happens in the cases of error. And I'm sure you had this case where you had issues with the performance of the server because you had an exception, and this has printed to logs many times, And this has slowed the server, and this has slowed the client. So you see how a simple exception printing, which is unpredictable because it happens only in case of errors, this could happen months and years afterwards, and it would drag the servers and all the things before it into errors. So maybe in case of exceptions, you want to print only maybe once. This is only one possibility, or have a better logging, which scales. In addition, what you could do if you have this unpredictability is to make it predictable in advance. So if you need some resources from a server, if you need some memory or some disks, allocate it all before. And when you reach the limit, send an alert. But because you pre-allocate it, then you get all the resources. There is also the notion of constant retries, like a warm-up to servers. So this is also a kind of a retry, but you are consuming precious resources of the servers because you keep warming them up. And you could use these resources for better. So the way to mitigate all this is to try and know in advance what your capacity is and pre-allocate it. For example, a simple example could be, I predict that I would have such and such users and such capacity, and my database is simply not enough. I need a higher scale of a database. So maybe you want to even pay or get more services in advance. I mean, you prefer to have additional resources unless you can dynamically scale up and down. You prefer to pre-allocate all this so that you already know that it will behave good in the failures, and not that once you have the failures, you will start retrying and start getting into fallback logic and all this stuff. Also, you can let simply the client handle the errors. This is especially useful if you let the whole process fall apart. So if the browser was trying to fetch a request and you let the whole process fall apart, then maybe it would try again, or maybe only 2 times. Maybe the user will stop and go into another link. In addition, whenever you want to fall back into a different logic, you can simply have this process more predictable. So you may want to utilize and return the actual fallback. If your fallback is, for example, a less precise score that you predict. So don't only return this less precise score in the special cases, but return it in more scenarios, even in true scenarios, because if this less precise score is good enough for you, it should be good all the time. We want to be less transient. We want to proactively try and test the system and give the feedback from the system in a constant, in a predictable way. So we try to avoid all the specific cases of retries and fallbacks in the system. We try to improve the systems from internally, because we need to invest time in all these special cases. We need to invest time in retries. We need to invest time in fallback. We need to invest time in failovers. And all this precious time, maybe you could pre-design the system to be more reliable. Because I know the scenario. The scenario is this. You call a server and you say, okay, what if it fails? I will do a retry. Okay? But instead of this, we should think, why did the server fail? Okay? Maybe the reason that the server failed was not justified. So you should go down to the root of the cause of this and check it. And in this way, we would get more predictable. And this is the rule. I mean, of course, nothing is perfect. Nothing is optimal. And we won't be able to be predictable. There is no company in the world and no person and no developer that can make code without bugs and that is fully predictable. Okay? The only thing I wanted us to is to open our mind to the rule, to the basic thing that predictability in distributed systems is one of the most important rules that we should be aware of and be mindful about. So I think this was a very super interesting, and I will see you next time.